Abhishek, take it away.
Thank you so much, Julia. And let me just share my slides and make sure that this works. Okay. Thank you. Thank you for a very stimulating lineup and already a very stimulating morning. Julia, you and Al really set this up really perfectly. And it's really inspiring work on how you can go beyond asking individuals or doing surveys on how data are being used to actually automating and making live that process. I'm also been thinking a lot about how do we value and measure the value of public data in my role as a faculty member here at UC Berkeley. So I'm going to talk a bit about some of that research and kind of what has come out of that. The motivation for this is many different sorts of public data sources. But think about something that the city of New York put up almost 10 years ago now called the New York Business Atlas. And the idea was that this would aggregate a lot of different sources of public data and make it available to the general public with the hope that this kind of data might be really useful for a variety of different stakeholders, right? So it had all of these different, expensive, challenging data sets to create in and of themselves, aggregated, which is another project, and then made public via this web platform. So if you were to think about what is the value of something as specific as the New York Business Atlas, how would you go about doing that? The city of New York itself has obviously tried to answer that question, and in some ways, what they came up with was a pretty long report. But in practice, a lot of the evidence of value comes either from individual examples of people using the atlas, maybe statistics about how much the website is used, or often even anecdotes or thought experiments such as this, where like improved decision making might help an entrepreneur access market research data that normally would come at a great cost. And so um, what I'm going to talk about today is potentially going beyond our current approaches to value public data, building on some of the other talks that we saw today, and think about what are some of the open challenges in doing that, and then what can be a way forward that requires a bit of philosophical thinking almost about what data is and how it affects value. So when we think about why one should value public data, when I talk to policymakers and those in government, they are asked this question all the time. They have to justify a budget around data, and now with the Evidence Act, they have to justify to Congress in a risk benefit trade-off what the value of data is. What we found is that the cost side of that equation or the risk side of that equation is really quite front and center and relatively easier to measure. So one side of this is obviously the financial costs. For example, there's a whole office of data analytics that had lots of people dedicated to creating the business atlas, and one can measure the value of their time and how long that takes. Perhaps even larger in many other contexts is the privacy costs, and not just the cost of developing the data, but what would happen if those data were leaked or if there were certain level of granularity in the data that we would like to provide, but we can't because of privacy. And so the sense is that these kinds of costs are obviously very important, but are also relatively easy to put your finger on. And so they have come to dominate the conversation. When we get to something like the Evidence Act and it's kind of the justifying the value, that part becomes much harder. And some of the reasons Al alluded to already, but let me kind of give you my spin on that. One is this idea of tracing, right? So knowing in publications, you can track who precisely is using data. But if an entrepreneur is downloading some data and using that to make a decision, they're not writing an academic paper. So you would never find out that they even used a particular bit of data in a particular decision. Often our downloads data or used data are anonymous. So we don't really know precisely what's happening when someone views or accesses a certain data source. Second is the potential applications or the uses of the data are really very diffuse. Some of them might be just curiosity based or very low value. And maybe there's a needle in the haystack that has such a big value that it justifies the entire cost of the data set. So this is heterogeneous value for very different users. And the types of value that data creates is often very diffuse. And so putting that all on one scale is really hard. Someone asked a question about like for the USDA, what is the effect of the data they've had on the entire agriculture sector? And on one hand, that's just such a hard question to answer because the kinds of decisions that those data would shape would just be so diffuse. it would be impossible to talk about that in kind of a single place. Third, and this is, I would say, one of the biggest points that I would like us to take away from this is data often have spillovers, and I'll talk about that in a little bit more, which is the idea that the value of the data can come not only to those using the data directly, but also to others who then emulate or copy those best practices or best decisions. For example, think of an entrepreneur that used the business atlas to detect a new neighborhood to locate in. If that cafe or that restaurant's become really popular, others will come in and the entire region might see some stimulating activity. And these other actors don't even realize that such a database exists that led to the original decision. But in capturing the value of the original data, we need to account for these kinds of spillovers. And finally, we need to build this idea of counterfactual thinking, which is really on the opposite side, which is sometimes we hear the argument that if the public sector didn't provide a particular data set, there'd actually be a lot of entry from private sector actors. And so in the end, we would get the same value that we would get, but it would come in a different way, right? And so thinking about what would happen if these data were not provided is another very useful thing to keep in mind. So the way I've approached this in my own research is what I call a mapping lens to value data. So think about something like traffic information that's shown on your favorite navigation app. If you think about how you were to value that particular data, there's kind of three pieces to it. One is the accuracy of the data itself. The second is a decision based on the data, which is which particular route that you might want to take to get to a particular destination. And third is the value of the change in that decision, right? So if you were taking the same route every day, and on a trafficy day, you happen to take a different route, the value of that information would be the amount of time that map saved you because you had access to that data. So how could we apply a similar logic to valuing other sources of data that we talk about? And the first thing to understand is that the kinds of data that we're interested in are often not that different than the traffic map. The main difference is that we might not be describing like a map of physical or geographic entity, but we might be describing other sorts of entities such as people, businesses, the atmosphere when it comes to environmental work. But often data has a dual property. Data loses any meaning if it is not associated with an underlying entity landscape. And so the first thing I want to stress for all of those who work in the data space is to think about data as imperfect representations of underlying entities, in much the same way that a traffic map is an imperfect but useful representation of the traffic in a given city. Once we kind of understand that representational view of data, the second point to stress is that there are many multiple representations for the exact same entity structure. In the very same way that Waze and Google Maps might give you different traffic for the same city, often we can collect different types of data for the same underlying sets of entities that we're interested in. And so that provides a lever for us to measure the value of data, right? So here decision makers might use one representation A as compared to the representation B. And so if I were to understand the value of this more granular representation, which probably costs much more, a representation A, then the way to understand that would actually be to look at the right panel here and to see how the decisions would be different. Put another way, the value of a live Waze map versus a street map is simply the difference in travel times that people would make when they look at these two different sources of information. So how can we operationalize this model that I really put in these three frameworks? First is to think about data as defining the relevant terrain and the associated decisions on top of those. Second, what are some alternate representations of the terrain? What other data could have been collected? Could it have been collected differently? Could it have been provided differently? I'll talk about this a bit more. And third, how can we start measuring the value of the differences in decisions that would happen as a result of these alternate representations? The benefit of this approach is it does a much better job of capturing these spillovers, capturing these diffuse impacts that might not always be evident when we are looking for explicit citations or explicit relationships between someone using the data versus not. And so the one thing that one has to keep in mind is that these alternate representations have to be really comparable, which is that they need to have happened for random reasons, right? So in economics, we often talk about randomized control trials, which is I randomly provide data for some entities and not others, and then look at how outcomes might differ. How might we operationalize that in real world settings? We rely on this work from the identification revolution that was awarded the Nobel recently. And I'll show you very quickly 4 case studies, just spending like 30 seconds. I have 5 minutes left. Perfect. Just spending a minute on each to talk about how one can operationalize this framework in real world settings. These case studies would come from the role of satellite imagery, the role of census data from this RDC program, environmental science, as well as someone related to Yelp. We've actually also done some work with commercial data. I'll talk about one in a bit more detail and then go through the others more quickly. We'll put the slides up online. So one of my first research projects looked at valuing satellite data from the Landsat program. This came in the 1970s. One of the early applications of these data was to guide mining firms to decide where it is that they want to drill. Very similar to an entrepreneur using the business atlas to decide where they want to locate a business. So here you see the Landsat image on the left, a heat map generated using these data that can then guide some firms to decide where it is that they want to locate their business. And so what we noticed is that even though Landsat were meant to be globally available, they were not in practice. And you'll find this with your own data sets all the time, which is that some parts of the world received much better data coverage because they were imaged on a clear day, while others were imaged on cloudy days or the data wasn't transferred. So even if the data was meant to be provided, it just didn't exist in the database. And so this is the kind of alternate representation that I was talking about before. And then we can relate the business decision, which in this case is the location or the discovery of a new mine, to this kind of variation. This is the same image now globally. Some places receive much better or earlier coverage, and other places receive worse coverage. And then we relate that to these outcomes. And what we see is before Landsat, places with better data and worse data had very similar exploration activity. But the places that happened to just randomly receive much better data had many more firms investing and many more gold discoveries being made, right? So even though the data itself wasn't meant to be in this way, it created this divergence. Again, we didn't have to rely on citations. We didn't have to rely on explicit download data, but we can use this kind of variation to say, look, the only thing that's different here is the quality of the data, and that's what must be driving these outcomes. There are 3 other examples that I'll summarize really quickly on this final slide for the sake of time. In these 3 other papers, in one of them we look at the RDC program by census, where there we don't rely on this like difference in the quality of the data, but because the RDC program requires physical access, we look at how opening up of a data center in a given university. So you can use changing access levels to assess the value of data. And there again, we find big spillovers. People who are not explicitly citing the data are benefiting from it. Third, you can use changes in cost of access. So sometimes your data might be provided for a fee, and then those fees might go up or down. And you can use those kinds of changes in fees to again look at how those changes in fees affect follow-on use. We show in the case of Landsat data that making these data much cheaper had like a 5-fold effect on not only increasing the amount of research, but also the diversity of research in terms of the kinds of people that work with the data and the kinds of locations studied with the data, right? So when we think about value, we might just not want to know the average impact, but also are diverse groups being affected and benefited from this kind of data, and we can do that in this framework. And finally, in this example with Yelp, we look at the role of Yelp listings in driving restaurant revenues. And there we look at data purchases. You had an existing data set and you went on a program to improve coverage. And we show that this kind of increase in coverage, we looked at the affected restaurants that were in the new coverage, but not before, and show that this improved coverage increased quarterly revenue by 5 to 10%. Right? So these are just a few examples of how this idea that your data are never perfect, and sometimes those imperfections are a problem, but almost there's also an opportunity to study the value of what would happen if those data were indeed perfect. So going back, if you were to value the NYC Business Atlas or indeed any of the other data sets you might be in charge of, you might want to think about what is the underlying terrain? How can we specify alternate representations, either based on cost, quality, or access regimes? And then how can we relate specific decisions to those data and then look at the difference? And we found that framework to be really valuable and a complementary approach to many of the others yeah, in thinking about the value of data. So thank you again for your attention. Thank you to all my collaborators as well, and to Julia for making this work possible. And look us up online if you'd like to learn more. There's a bunch of references here that I'll share also. Thank you.